data processing.
Thank you, Susie. And so for this presentation, I will work with my colleague Josh Ward to share some lessons learned experience on the OBD standardized data processing. So we divided this presentation into parts. First part, I will just introduce some background information about the OBD standardized data requirements in regulations and how it's getting more and more complex. And Josh will then share some lessons learned and some experience from Stellantis' perspective. So standardized data requirements in regulations becoming more and more complex. And since this was introduced in the OBD2 regulation in 1997. And so such complexity is mainly driven by the revolution of the communication technology used for the vehicle's E architecture, or maybe the demand of more diagnostic services from the service community, and maybe the incremental need of the report mandated by different regulators. As you can see from a simple diagram here, the standardized data could, in nowadays, could require more hardware to support, and could require extensive diagnostic services, could need more testing, not just from the developer perspective, but also verification and all those things. And also, the regulators could require more reporting to be submitted to them. And in addition, the standardized data requirements could drive more updates on the SAE or ISO standards, for example, as well as some kind of additional technology support, like OTA. And for this, Stellantis side will have a presentation on Thursday to talk more about OTA technology usage. So how the standardized data becomes today's version in OBD regulations so complex? And in short answer, per our observation, is we think it could be contributed by the incremental or some step changes in the standardized data requirements in OBD systems required by different regulation globally, and over the past 2 decades. So these kind of added up changes make the OBD standardized data requirements getting so complicated. And we're just using, from our observation, using the change in US CARB OBD regulation and on the standardized data requirements example to illustrate that how this is becoming so complicated. Okay, first of all, starting with before OBD2 is OBD1, right? I mean, as we all know, OBD1 is so simple, 3-page. And essentially, maybe our observation may be wrong or incomplete, but our observation looks like there is no mandate on the standardized data requirements and no associated testing or reporting requirements at the OBD1 stage year. And then 1997, that's first official OBD2. For all the rest references of the OBD regulation by CARB, we always use the OAL, which is the Office of Administrative Law approval date for those regulations, OBD2 or HDOBD, so to identify each version of the OBD regulations for CARB. So for the 1997, it's an official first OBD2 regulation, and it refers to multiple SAE standards, like have the EO requirements approval for J1939, and there was no PVE testing requirement at the time. And then 2002, the OBD2 regulation goes through updates, and they added OPV testing requirements, some facing communication protocol, and eliminated the usage of J1939. Okay, so for 2004 is the first official OBD regulation for heavy-duty side, which is called EMD at the time. And that's a very simple version of the heavy-duty OBD requirements with no standardized data mandates in general, and there's no associated testing and reporting requirements. For the 2006 version of this, the first modernized heavy-duty OBD regulation, and so they have similar, try to have similar language on standard data requirements as OBD2 at the time. And J1939 is allowed in the heavy-duty OBD, and with different phrase requirements. And in 2007, the OBD2 regulation goes through a major revision, and they try to harmonize permanent fault code requirements with heavy-duty OBD, and also added additional requirements, various different requirements in standard data requirements. And then 2010 is the first major revision of the heavy-duty OBD, and for that version, they have added more requirements on the data connector, as well as reporting of the ECU name, for example, and also adding the EIA-AECD tracking requirements in that version. And there was also revisions in 2012 and 2013, and for the OBD2 change, there were some minor changes in that version, and they have like readiness requirements, they updated that. And one of the major revision for the modern OBD, CARB OBD is 2016 version revision. And in that revision, they make big changes on OBD2 regulation. And mainly to update standardized data, they updated readiness requirements, test results requirements, and data streaming requirements. And also as they updated so-called engine runtime tracking at the time for the section, renamed that to be the vehicle operational tracking, VOT. So that's when the VOT becomes a name in nowadays. And then 2019 is a major change on the heavy duty side, mainly try to harmonize lots of requirements, with the OBD requirement at that time. And introduce, they also having added NOx tracking requirements, and also adding lots of one more requirements added in that version is they added the data reporting requirements for the over-the-air OTA reprogramming requirements for the heavy-duty OBD. And now, the later version, and maybe something, there's some minor changes in between. And the later version of 2022, we all know that this is the one introduced the UDS on OBD, and which is the J1970-2 requirements, which is one of the biggest change and in recent years. So coming back to this presentation, go through the history, and there were additional changes that CARB also putting in, not in the regulation, but in mail outs. And the mail outs is something for the OBD standardized data reporting, like 2006 and 2009. They have mail outs to introduce the rate-based reporting, as well as the KRD CVN submission requirements for OBD2 and heavy duty respectively. And then 2018 and 2021, they have data recording requirements of over-the-air reprogramming vehicles and how you submitted those reports. And of course, in the recent 2023, the mail outs ECCD 2023-01 introduced new reporting templates for PVE1, PVE2, PVE3, and MST. So with all this, the key takeaway from this is standardized data requirements in US, it set example, how they grow in the past decades. And they started from almost zero, right? From the OBD2, OBD1 requirements, goes to nowadays, it's become very complicated. And it could be one of the most complicated portion in the OBD regulations nowadays. And some of the requirements are driven by the evolution of the communication technology, like go from J1979 Classic to J1979-2, and also some and utilize the UDS technologies. And some other is driven by to satisfy the need of more diagnostic services from the service community, and 3xDTC and more service data to provide to the service community to help troubleshooting and all those facilities for the service communities. And others could be driven by the incremental need from the agencies, to provide more information to them, like the KLID CVN quarterly report, PV testing report, MST reporting. And globally, all of the countries across the world, I would say it's the same trend. That means, all these complex requirements poses more challenges and to basically all OEMs. And some other regions like like European countries, they have like OBM, the OTA requirements, and those kind of reporting requirements is also very challenging. So overall, all these big challenges to OEMs, this big question is how to keep up with the complicated requirements while ensuring the compliance, right? And in the following section of this presentation, and my colleague Josh will share more experience and lessons learned on the PVE 1 and 3 testing and reporting. Josh, please go ahead.
Okay. Oh, what's wrong way? So I'll go through the PV1 selection of test vehicles first. So there's multiple approaches to satisfy this regulation. We compared an engineering team to a plant-based team. We kind of use a hybrid approach. I'll cover that a little bit later. So an engineering team, some pros, they only need one set of tools and there's less people, so it's much easier to manage. For a plant team, the pros are typically it's less cost. Current end-of-line testing staff can be trained to run the test. Test frequency can increase because they can test as soon as the vehicle rolls down the line. Some cons to that is managing multiple plants across North America and then also internationally. So I'll go through the plant testing process first. So we utilized an internal plant broadcast system that's already used for tracking of builds within the plant. So we created a new landing screen that's specific to J1699 testing. It utilized group codes that we use that are associated to components and emission related parts tracking to track the ECUs that we need to test. So as a new ECU gets added or determined to be a propulsion related part, we add those group codes and update them so they get flagged for testing. So once the vehicle is flagged for testing, it's pulled off of the line, the tester conducts the test, and that's across the board. So that process is documented and officially published for all of our North American plants to follow. And it's really created a much better testing environment where we get a lot of results, we can analyze a lot of data versus just having like an engineering team where you'd occasionally get test results back. So to kind of go through a workflow, in green, we have a pass test. So if the test passes, the results are emailed to my compliance team, and then we submit them right to the agency. If the test fails, they still email the results to us. We triage to determine issue severity. We could communicate that right back to the plant team. So if if the vehicles need to be held, if production needs to stop, anything like that, we can quickly let them know that that needs to happen. Once that happens, we can have a second round of triage with engineering, and then we can report the issue to the agencies. So a lesson learned with plant testing is just teaching the teams how to perform the test. J1699 OBD standardized data, we all know is a very complex thing. So it's not an easy thing to teach someone to do. So we conducted on-site demonstrations when possible. It allows for my team to have a personal connection with that test team. So if they have issues, they run into problem testing, their DTC procedures not working, they can reach out to us, ask their questions immediately, and we can get them a quick response. We also created a full walkthrough of the J1699 test script and PowerPoint, including those fault procedures and all the user prompts, and a fault procedure for every deck ECU across our full portfolio. We're also teaching the teams the importance of compliance in the delivery of the results. We created a sign off for each plant to sign at the beginning of the year or at the start of production of a new model year to ensure that they understand the process requirements and the testing process itself. That ensures that there's engineering support when it's needed. And then if there's a compliance issue, we know they'll act immediately. We also created an inbox that's specific for J1699 test results that the plant can send the log files directly to. That way, if there's ever a change in ownership, management, anything, that inbox will be there and whoever needs to have access to it can get access to it. So a second lesson learned is international plant testing challenges. So being based in North America, we've got vehicles that aren't built here. So there's different production systems in those plants. So tracking part numbers where we have a nice system set up here, we might not have that in place in an international plant. So that's more difficult in general. We have time constraints. So communication of test results can happen overnight or early hours in the morning. Obviously, we try to get to those results as soon as we can, but we're subject to the time zone. And then adherence to corporate process. It's a lot easier to enforce something when I've gone to the plant, talked to a person, talked to the test team versus doing it virtually. I think a lot of people probably can sympathize with that. And then the biggest challenge is training teams at the plant. So right now we have an engineering team in Europe that does our testing. So kind of a hybrid approach to what I outlined in the beginning. They do the majority of the testing, and we've been unable to do any like face-to-face on-site training so far. So another lesson learned is the unique calibration testing requirements that we have. So testing in the regulation is called out for each unique calibration. So we maximized efficiency by utilizing flexibilities allowed via regulation by discussing things with the agency to seek a feasible solution, finding commonalities between our OBD groups and our test groups. So something like the vehicle has a similar powertrain configuration, and then eliminating new software from testing cadence that's driven by only like non-OBD features. So, or no changes to standardized data. So if we have a running change or a software fix go out, we look at it, we determine there's no OBD impact. We know we don't really need to test it. It can be cleared from the test cadence. So now going to PV3 a little bit. So PV3, 15 different VIN samples are required per emissions test group. I used our example here. So you can get up to 150 vehicles depending on the number of test groups a company decides to utilize. I used our example across 5 model years. The total number of data points would be about 2,300, a little bit over, for just 15. Obviously, we can do better than that too. So an experience share on this, we made some improvements to our PV3 reporting process. So we have a team that's on site that interacts with dealerships. They require acquisition of customer data to determine what VINs have accumulated mileage to know what vehicles to go after. And that requires a standalone team in California to gather the data. When we're adhering to CARB, EPA obviously would need to do more states. We also have an alternate data feed that utilizes dealership scans when a vehicle comes in for service. So when the vehicle comes in, we hook up our tool. It sends diagnostic messages in the standardized format to get responses from all the deck ECUs. That allowed us to expand our data collection and allowed for additional data analysis. And then it also allowed us to get additional state data outside of California to use as well. And then we also did some grouping of data samples. So we looked at commonalities between test groups similar to what we did for PV1 testing. The example I use here that I always run into is box on versus box off trucks, or standard versus chassis cab vans. The chassis cabs are such a low volume that we try to group those together when we can. That way we can meet our reporting requirements. So to summarize, OBD standardized data requirements are becoming increasingly complex, and the trend continues with recent and upcoming global rulemakings in the US, EU, and China. With the US OBD standardized data development history example that each outlined in the beginning, the complexity is driven by the combined effects of the evolution of communication technologies, the demand for more diagnostic services, and the incremental needs of service data mandated by the global regulators. For any OEM, it's a big challenge to keep up with the complicated requirements while ensuring standardized data compliance. Our experiences on PV1 and 3 testing and reporting are shared to demonstrate our efforts to tackle those challenges. For the foreseeable future, the introduction of J1979-2 PV reports involve more standardized data such as SMAD, and to effectively collect the data and generate the report per the agency required templates will present even more challenges. So Stellantis will continue to tackle the OBD standardized data challenges, and we hope to share more experiences on remote monitoring with OTA technology and more usage of in-cab display in future symposiums.